Hi there and welcome to the final statistics lesson for Year 1 A-Level Maths, which is after one-tailed test, two-tailed tests. And the basic thing about this is we're splitting our significance into both ends. So whereas one-tailed test was, I might be saying I think the probability has improved or got worse, I'm just saying that it may have changed. So it could have got better or worse. So if I've got a 10%, well 5% level of significance test, I'm actually testing at 2.5% at both ends at the same time. So my null hypothesis will be the same, but my alternative hypothesis will just be saying it's not equal to that, and then we're looking for one of those changes either end. Okay, let's have a little look at some examples. Okay, so here's our example. Pause the video, give it a go. You should have had enough of an idea to be able to give this at least a shot. Right, so we've got a 5% level of significant test. I'm always going to start off by sketching what's going on. I've got a sample of 10 people. In fact, as I know I'm going to be using a binomial distribution, I'm going to do my little setup here to say it's a binomial thing. We've got 10 people, so that's 10 trials. And if it's 2 to 1, the probability of ordering a vegetarian meal, if 2 to 1 a non-vegetarian, is going to be 1 in 3, isn't it? So that's a 1/3 chance there. So if that's the case, the most people would be 0, the maximum would be 10, and if I go 1/3 of the way along there to 3.3 recurring, that would be your average idea. That's what we're going to be expecting to happen more often than anything else. And we're looking for a 5% level of significance, so that means 5 divided by 2 is 2.5%, could be more, 2.5% being less. And all I need to do now is pop into the calculator and do the probability of x being, well, as they're saying that one person ordered a meal and 1 is less than the expectant mean, it's going to be less than or equal to 1, and then we just need to pop that into the calculator. So, little reminder, we go to our menu, we hit 2 for statistics, the bottom would be 0, the top would be 1, there were 10 people at the restaurant, it's a 1 in 3. Now, you can do this with the fraction button, but you have to hit 1 and then the fraction, otherwise it doesn't work, it doesn't do it as a normal thing. So 1 over 3, when I press equals there, that shows me I've got it right because it's 0.333, and that's given me a probability of 0.10404, so 0.1040. Now that is more than 2.5%, isn't it? That is equal to 10.4%, which is more than 2.5%. So for me to reject my null hypothesis, that's what's going to happen. Oh, I forgot to do a null hypothesis, didn't I? So just a quick reminder, the null hypothesis would be that the probability is equal to 1/3, and the alternative hypothesis would be that the probability is not 1/3. And then I've got that, so then I need to say that we no, we don't reject it, we accept the null hypothesis as there is insufficient evidence to suggest a change. And that's because 1, as a result, is somewhere in here. It's in this middle bit, which is what we're expecting to happen at that level of significance. Now that was all part A. Part B, the p-value is actually saying what probability are we really saying would happen according to this. Now that's 10.4%, which is 0.104, but because it's two-tailed, if it was within what we wanted, then that would have been a 20.8% would have to be the amount that we were saying for our significance before it would go. So the p-value is saying what real significance would this result be if we're talking about a two-tailed change. So the p-value is going to equal 0.1040 times 2, which is 0.208. Okay, I'm going to give you 3 more to have a go at. Pause the video, give it a go, and then I'll go through it. So we've got a machine glass bowl. So first thing to do, 0 to 20 is the most amount. They're saying that 1 in 10 has a crack in, so we are expecting 1/10 of 20 is 2. So we're expecting 2. That's our expectant mean. That is going to be the peak of our distribution. It's going to look something like that. At the 10% level of significance, we want 5% there and 5% there. We need to state our hypotheses clearly, so you should have HOP equals, and before I do that I would always say, what have I got in terms of a binomial? I've got a sample of 20 and 1 in 10 bowls, so that's 0.1, and we're looking for a probability equaling 0.1, and our alternative hypothesis is that that is not true. So it's the same thing with a line through the equals sign. Now, what do we get? We're looking at the probability, so we're talking about that 1, and I'm thinking that's probably going to be in there somewhere, but let's find out. We're saying the probability of x being smaller than or equal to 1, so our result being no cracked bowls or 1 cracked bowl, and you're getting your calculator going, back to there. Exit gets us back, doesn't it? So 0 and 1, same as we had before, but this time we've got 20 trials and our probability is 0.1, and that is saying 0.3917. So I'll write that down, 0.3917. And for that p-value I'm going to write down everything that I've got in my display there, 4699. Right, so that is significantly more than 5%, isn't it? More than 0.05. So as a result of our test, we can say there is insufficient evidence to reject the hypothesis, the null hypothesis, the probability has not changed. Now, stating the p-value of the test, the p-value for part B is going to be, we need to times that by 2. So if I just go onto my thing and I do that, if I times that by 2, I get 0.39174699 times by 2 is giving me 0.7835 So that rounds to 0.7835. Right, 2 more to go. On to Agnetha and her carrot. So give this a go. And hopefully you should have something looking like this. Okay, so I've put in my null hypothesis and my alternative hypothesis. I've done my little sketch. I've got 7.5 there because that's a quarter, 25% of 30, so that's my expectant mean. That's important because Agnetha has discovered that she's got 13 carrots that are longer. So 13 is somewhere around here. But is that actually within that 5% zone? That's what we're thinking about. So then we're going to be saying, and that's important because that is more than we would expect. So therefore, we're not going to be looking for the probability between 0 and 13. We're going to be thinking between 13 and 30. So we're thinking the probability that x is more than or equal to 13. And popping that into the calculator, binomial BCD, we're going to lower 13, upper 30, number of trials 30, probability 0.25, and that's actually 0.02159. 0.0216 to 4 decimal places. Now that is less than 2.5%, isn't it? Which would be 0.025. And that means that at this level of significance, that's actually going to be in that zone. So that means that we reject the null hypothesis and say that there is significant evidence to suggest that Agnetha is right and it has changed, the fertilizer has changed the probability. You could actually even go further and say that it has made bigger carrots, hasn't it? Okay. 1 more to go, folks, and here it is. Pause the video and give that a go. Right, so start off with the, I think now we are expecting 96% chance of success. So that is right up near this end, isn't it? 96% of 75 gives us 72 as our expectant mean. So we are talking something like that. And we're looking at 10% level. So you've got a 5% there and you've got a 5% there. But the question is, where on this scale is that value there? Is 63 going to lie in it? So your null hypothesis has got to be that the probability equals 0.96. Your alternative hypothesis that it doesn't equal 0.96. And setting up your binomial distribution, you've got a trial of 75 patients and a probability of 0.96. And then you're needing to find out, because 63 is below the expectant mean, maybe it's there, maybe it's in there, you're needing to go for the probability that x is less than or equal to 63. So we need to chuck that into our calculator. And the smallest being 0, the highest being 63. Altogether we've got 75 trials and our probability is 0.96. And whoa, that's a tiny number, isn't it? 4.1744 times 10 to the negative 5. So that is actually equal to 0.000417, which is clearly less than 0.05, which would be the 5%. So our final test would be there is sufficient evidence to reject the null hypothesis and the manufacturer's claim as the cheaper test and, strictly speaking, all you have to say does not give the same level. You don't have to say it's worse, but it clearly is worse. Does not have the same probability of success. It's still telling quite a few people that they've got this problem, but you really want to be a bit more sure than that, don't you? 63 is nowhere near 96% of 75, and it's not as good. Anyway, that's all of that, folks. So well done, and see you in year 2. Bye bye.